you today, or even yourselves can have a look at it later on. Okay, so Martin.
Thanks for that. So good morning all, Sawadee Ka. My name is Professor Martin Crane. Some of you might have met, I met already in OCSC in Bangkok in November last year. I'm just here this morning to introduce you to the School of Computing, and then I'll hand over to Dr. Renat Verbruggen to talk to you about the Masters in Computing degree. So what is DCU? DCU is a medium-sized university in Dublin, Ireland, on the east coast of Ireland, to be precise. And Ireland is on the northwest coast of Europe. The university has about 17,000 students, and the school has about 1,200 students. Of these, about 1,000, just under, are on our 3 undergraduate programs, 250 taught postgraduates, of whom most on the Masters in Computing, and about 80 are research postgraduate students. We have 2 world-class national research centres based in our faculty, and our research directly informs our teaching. That's to say, our research impacts on how we teach, and we teach the latest and most up-to-date methods. We have good contacts and are heavily engaged with employers. We are 23rd in the world for graduate employability after 6 months. In terms of world rankings overall, the latest QS rankings has us 201 to 250 in the world. And that says a little bit about us briefly in a nutshell. So without any more ado, you will want to hear about the Masters in Computing degree, and I will hand you over to Professor Verbruggen at this point.
Thanks, Martin. Okay, so as Martin said, we in the School of Computing are a rather large school within a university that is expanding a lot. Okay, so we currently have 3 academic campuses and 1 industrial. And what that means is that we have a range of different facilities right across Dublin. Where School of Computing is based in what's called Glasnevin. Okay, and Glasnevin is the largest campus that we have. Because we have both undergraduate and postgraduate, we have both, if you like, a range of computing being taught and also being researched. So what are these various things that we were talking about and that Martin mentioned? The core idea, as he said, was that we tried to link together our research and our teaching and our work. So in that sense, the findings from our research update and help us to indicate what we should be teaching you. And then how that teaching works with our students gives us the feedback as to what other research would be useful. But the research itself, while there is also fundamental research being done, a lot of it is industry-based. Now, I can't give you all of the companies, but I'm going to give you a flavor for some of them. So we have research collaborations all around the world, okay? And the research varies from research with the big tech companies like Samsung, Huawei. Obviously, Google aren't even there because they're in Dublin. I'll show you that in the next slide. But also the IBMs and the Microsofts and over as far as Fujitsu and down to Cisco. So there's a huge range of different relationships that we have set up with our research and with our development seminars that we get involved in as well. I got the careers office here to develop this little chart. Now, I apologize in advance because it's so much information on one page, but just to kind of show what's happening, it gives you an idea of down here, the kind of salary band. So this is in euros. So, you know, the salary band of people coming out is up and around 35, 36,000 euro, which as starting salaries go is pretty impressive. Up here, there are indicators of how relevant the program was, way up in the 80s. Was the qualification needed up in the 90s? The likelihood of doing the same course, getting other people to do it up in the 80s as well. And interestingly, the occupations, while most of them are in information communication, a lot are also in financial now. So as you all know, finance can only run based on its IT infrastructure. But that's not only true. Now, of course, it also can only run if it can look after its data. So the kind of work that we do in data analytics and in AI is now incredibly important for financial institutions. The next slides give more, I suppose, granular level indication of companies. All of these companies are based in Ireland, okay? I'm not going to show you them all or mention them all, but I'm going to give you a flavor. Okay. So, as you probably know, Ireland is the only English-speaking country left in the European Union because Great Britain has left because of Brexit, okay? But even before that happened, an awful lot of companies, mainly American, but also Eastern, wanted to locate in Dublin as a place where they could get really good talent and also service what they call the EMEA market, which is Europe, Middle East, and Asia. So as a result of that, we have the headquarters of Amazon Web Services. We have the headquarters of Google. We have the head of EMEA Google. We have the headquarters of Facebook. We have the headquarters of any company almost you can think that trades from TikTok all the way through all the big consultancy companies. And they're all based in Ireland, and most of them in Dublin, in an area that has been proverbially called Silicon Docks, because it's down near the old dock area. So as a result of that, these companies directly employ either our students or our interns. Okay, and then obviously the IBM, they have a big campus just up the road here, and then all the way down through Oracle, OpenNet, and then small little companies that work on things like Medtronics and Siemens, and finally, obviously the Xeroxes, the Verizon, and etc. Okay, so we have a lot of connections. So what do we do? Well, we have 3 undergraduate programs. One is called business computing, and the name explains itself. It is, oh, by the way, one of the things that also characterizes DCU, as always characterizes, is that our courses are practical. In other words, when we say business computing, we mean that those students can program as well as use whatever packages and facilities are there. We don't mean that these are business computing students who go out knowing some Microsoft products, okay? They all know how to program in Python. They all know how to develop web pages. They all know how to build enterprise applications, okay? So that's business computing. And then there's the classic computer science, which range across all the computer science elements, including AI, machine learning, et cetera, et cetera. And in computer science, for example, they do projects in 3rd year and in 4th year. So they really hone their project development skills. And I mean application projects, obviously. And then we have a data science degree, which is an undergraduate approach to data analytics. So you learn all the stats, you learn all the data visualization, you learn all the machine learning, you develop applications. And then what's probably more interesting to a lot of you is the idea that I'm the director of the M.Sc in computing. And we have, I suppose you could call them majors in some countries, we call them specialisms. So we have a specialism in artificial intelligence, data analytics, secure software engineering, and this year we're launching a natural language processing stream as well. And then we also, but only on a part-time basis, we run a blockchain and distributed ledger technology major and a financial technology and innovation. So what does the M.Sc try to do? Well, it's a taught M.Sc, and it lasts for a full year, calendar year, not an academic year, okay? And in that year, our idea is that you should, as a graduate, get what we call cutting edge skills that allows you to produce high quality software and systems, delivering solutions in the area that you've chosen, okay? And the approach that we take means that we expect people coming in to know how to program. We expect people to come in, as I always say, not to be afraid of mathematics, right? And you come in with that, and then we build on it. So therefore, our entry requirements are a second-class honors degree or higher in computer science, computing, or computer applications. And obviously, if you were a non-native speaker of English, then we have an English language requirement, which is all available on the DCU global website. Now, we expect you to be a competent program in, we don't insist the language. It could be Python, it could be Java, it could be one of the varieties of C or C++ or C#. And also, we want you to be, what it says they're comfortable with advanced mathematical concepts. So what do I mean by that? Well, I mean, you should know what a statistical probability distribution is. You should be able to deal with mathematical concepts in, for example, calculus. We don't do much calculus in the course, but the understanding of a derivative and what it means, etc., is important. So all of the information on the courses are in this link here. And then within that, you will get links to what we call our modules. And I want to show you the structure. Now, I'm not going to show you the structure of every major, but I'll give you one as an example. So this is the M.Sc in Computing Artificial Intelligence major. So in the first semester, there are 4 modules, okay? And we have our semesters set up now so that they start in early September and they end in December, okay? And in December, you will have exams in those modules, all right? So it's kind of 12 weeks of teaching, break for a week, and then exams. So the kind of things that you would be doing in AI, you would obviously have a Foundations of AI course. Then you have a course called Professional and Research Practice. And that's to try and develop your skills away from what you've done at an undergraduate level, when everything was about developing applications, to research. And why is research different? Well, research is about doing something new and novel and being able to explain why it's new and novel, being able to read research papers, being able to write research papers. And as well, on the professional side, understanding legal implications of computing work and ethical implications, increasingly important, okay? Everybody does that. And then statistical data analysis. Again, stands to reason. You're going to be making claims about the AI work that you're doing. How can you justify those claims statistically without understanding concepts of significance, concepts of covariance, all of that? So you need to know about statistics. And then, obviously, you'd need to know how to show and develop ways of explaining the data that you have manipulated. And that's data management and visualization. So they are, they're the foundations of your AI course, okay? They're the things that will give you what you need in order to move on into the second semester. And in the second semester, then you will have more intense courses like data analytics and data mining. So getting the data to answer questions for you, profiling it, etc. And obviously machine learning, developing machine learning models, right? And justifying the machine learning model and running them and developing pipelines, etc., etc. And then we have choices. We call them electives. So you can go down the statistical machine translation model if you're interested in the NLP kind of approach, or you can go down the mechanics of search model if you're interested in, if you like, that whole idea of creating your own search models and also understanding the optimization of search within AI. And then we have another core module, which is a very broad module that goes across AI, called information and information seeking, and the concept of using AI for that. Okay, again, 12 weeks and exams. So we're in week 11 of the second semester now. And we're the first week in April. So we'll have one more week next week of teaching. Then we have a break of a week, and then we have our exams. So all the exams are over in May, right? Very early. But down the bottom, it says, additionally, artificial intelligence practicum, 30 credits. What is a practicum? So we borrowed the notion of a practicum from MIT. And what we developed was the notion that most MSCs get you to do a dissertation. It's about 120, 150 pages. In that 150 pages, about 50 pages is background describing your area. About 50 pages, 40 pages is set up and explaining what you're trying to get done. And about 20 pages is what you actually got done. So we've got rid of 100 of those pages. And instead, we ask you to write a research paper. We want you to do all the work. We want you to do an experiment, a research experiment. But we don't want you to give us all the background that we understand. We want you to explain what you did in a research paper that should be publishable quality, right? That should be publishable. And we try to publish them in conferences. And some people add to them and publish them in journals. So that's the idea. So you end up with 10 or 15 pages of a paper, everything in that. You give a presentation, a viva or a viva, if you like, viva voce, where you give a presentation, you explain your work, and we question you about your work. And that's it. That all happens in August, everything over then. So there you go. That's what a year looks like in an MSc. Okay, so I'm very happy to take your questions. If you prefer, you can type them into chat. So I'm just looking there to see what's in chat. Okay, yeah. Just Claire has put some information in there. But I'm quite happy to take the questions directly if you want to ask them to me directly. Or if you prefer, you can type them into chat and I can answer them there. Thanks very much for listening, by the way.